In the last video, we considered the first 7 definitions of Euclid. There are some interesting insights and reflections about those definitions, and I thought we'd spend some time going over those today. So before we do that, of course, if you could just hit the subscribe button, that would be awesome, and then also the notification bell. I'd really appreciate it. So let's reflect on these definitions. The first definition, of course, was a point. A point is that which has no part. It has no length, right? And also the extremities of a line are points. So we've got some insight into what points are. The next definition of a line is interesting. A line is breadthless length, or length without width, right? As soon as you add width, of course, then you have a surface. So it's pure length. You can think of it that way. Now I wanted to contrast that with the modern definition. The modern definition of a line is an infinite set of points. So let's think about that and the logic of that for just a moment, right? If a line is an infinite set of points, and a point is that which has no part or that which has no length, right? And a line is pure length. How can you have something with no length and you put them together to all of a sudden get length? So there seems to be an inherent contradiction there. So I don't find that to be a very good definition. The modern definition is that it's an infinite set of points. Now it's true that a line contains an infinite set of points. That is very true. And between each point, or 2 points on a line rather, there's another infinite set of points. And that's a little mind-blowing, right? So I think Euclid's definition is superior. It's more in line with our common sense of what a line is. So that is the first insight about what a line is. Now, in this video and the remaining videos, we're not going to make a distinction between a line and a line segment. I know they do that in modern geometry. So when we speak of a line, it's going to be a line segment. So it's going to be, again, not an infinite line, but a short line, right, as it were. So for now, I think that's going to make things easier. And again, our videos are all about geometry, pure and simple, right? So we really don't want to get bogged down too much in the notation. I want to more concentrate on understanding of the concepts, and especially later the theorems and the proofs of those theorems. So the next insight that we can consider is the straight line. So again, we defined the straight line in the last video. A straight line, as we defined it, is a line, right, which lies evenly with the points on itself. That was the definition. That is the definition that Euclid provides. So that's interesting. So he doesn't define a curved line. So that's kind of an interesting note, right? He has no definition of a curved line. And you don't need a definition of a curved line. And the reason for that is because a straight line and a curved line are contraries. So as soon as you define one contrary, you get the other one for free, right? So once you know what a straight line is, then you automatically know what a curved line is. You just say it's a line that's not straight. So I thought that was interesting. It's like anything, right? If we understand hot or heat, we can get an understanding of what's cold. What's not hot is cold. So any contraries are that way, right? Light, right? Once we understand what light is, then the contrary, which is not light, we get that for free. So that is something that is worth noting. We don't need to define a curved line. We get it for free once we understand what a straight line is. And the last insight that I want to provide here is kind of the symmetry of the definitions, which is quite beautiful. Again, he starts with the first definition of a point, which is that which has no part. But then the second, third, and fourth definition are symmetrical with the fifth, sixth, and seventh definition. So the second definition, which is a line, is breadthless length, goes with and is very symmetric with the fifth definition, which is a definition of a surface, right? And a surface is that which has length and breadth only, or length and width only. So they kind of go together. Then definition 3, which is the ends of a line or points, goes with definition 6, which the edge of a surface are lines. So there's some beautiful symmetry there. And then lastly, the fourth definition, right? Again, the definition of a straight line is a line which lies evenly with the points on itself, goes with definition 7, which is a definition of plane surfaces, or a plane surface. And a plane surface is a surface which lies evenly with the straight lines on itself. So there's some beautiful symmetry there. So right off the bat, we get this understanding of these definitions, and we see this beautiful symmetry and order that Euclid is establishing. And it's kind of a precursor to the entire work, where he's going to be establishing a beautiful order in all of the theorems, right? Well, we're going to go over the first 6 books, but he has 13 books of the elements. So I hope that's helpful, provided some insights. We'll continue with the rest of the definitions in the next video.